everyone, welcome to our first video. So I usually like to use um, just my OneNote or whatever to go ahead and do notes. And yeah, I just use like a free app of like recording the screen and stuff. So if you have any issues with doing the videos or anything, please let me know sooner rather than later so that I can make any corrections. So our first section that we're going to be going over is R2. And so the R is supposed to be like review. So these are supposed to be review sections. And so the first one that we'll go over is integer exponents. And so the first thing that I want us to do is to go over some rules of exponents, review a little bit of those. So we're going to go through some rules of exponents. The first part is if A and B are non-zero real numbers, and M and N are integers, then, and we'll see some rules happen. It's really important to know that A and B are real numbers, so as long as they don't have I in them, we're good. And then M and N are integers, so integers are going to be like whole numbers, but they could be negative, positive, or also zero. And so here are our rules. So first we have, if we have A to the power of M times A to the power of N, if we have two things with the same base, we can add the exponents together. So multiply two things of the same base, you add the exponents. If we are dividing two things with the same base, we can subtract the exponents. Now be careful here. You can also do N minus M. The only thing that changes is that it would put it in the denominator. So if you pick this one to do like as your first number, then it'll end up in the denominator. If you pick the M as your first number when you're doing the subtraction, that'll put it in the numerator. And we'll see some examples of why maybe we would want to use the bottom one or something like that. If we have a power to a power, so like a power raised to a power, you are going to multiply those exponents. If we are multiplying things and they're all raised to a power like this, like in parentheses, that power can distribute is kind of a word we can use for this. So it would just go to both or everything in those parentheses. As long as you only have multiplication, and then this also works for addition. Oh, I'm sorry, I didn't mean to say addition. Division. Division. There we go. So it only works for multiplication and division. It does not work for like addition or subtraction. For instance, like if you see something like a plus b to the power of m, we're going to have to like FOIL that out. That's not something that we can distribute the exponent with. Anything to the power of 0 is 1. Something you might find interesting, the reason for that is because if you ever have something over itself, it's supposed to just reduce to 1. But also, if you subtract the exponents, you get 0 as your exponent. So it's really just about consistency. Anything to the power of 1 is just that thing, doesn't change at all. So a lot of times we're not going to write the 1, it's just kind of understood. Um, so if you don't see an exponent, there is really an exponent there, it's just 1. Also, if you have a negative exponent, think about if you remember what to do for that. It can flip into the denominator. So any whole number can be written over 1, and then you can bring it into the denominator to make it a positive exponent. You can also go backwards with this, like if it's 1 over a to the negative m. If you bring that into the numerator, it'll become a positive m. And it would technically be over 1, but something over 1 would just be itself, so we don't have to write it. Next, I want to show you a little bit of I don't know if that I'd call it really a trick or anything, but we're kind of just using some of this information. So if we have a over b, and we say it's to the negative m, we want to look at like how can we simplify this? So since the negative m is really is really going to both the a and the b, I'll need to switch both of them. So the a will have to come to the bottom and the b will have to go up to the top. Now another way to do this is that you can just flip it without like before distributing. So I could say b over a to the m. So I can flip that way. Be careful though. So let me show you a little bit of an example. If something said like 2 over 3 to the negative 2. So first thing I would probably do is flip both because I have that negative exponent on the outside. But it's because both pieces are in the parentheses that the negative is going to both, so that's why we flip both. And then I can simplify, so 3 squared would be 9, and 2 squared would be 4. But then let's say that I wrote out for you 2 to the negative 2 over 3. See, this is very different because the 3 is not involved with that negative 2 at all. So nothing's going to happen with it. The 3 would just have to hang out. The 2 to the negative 2 can come to the bottom to make it a positive 2. And then we always need a placeholder at the top, so we'll have to just say 1 as like a placeholder. So this would be 1 over 3 times 4, so 1 over 12. So careful there. Also, you're not really allowed to do this kind of thing if you have any like addition or subtraction in there. So let's say we have something like this. This, we can't do much. Maybe we could bring that 2 up to the top. The 3 can't come down though. Like this 3, that cannot come down because of this plus. Oh, I didn't mean to erase, sorry. it's because of this plus right here is blocking that from happening. So if you've got pluses and minuses going on, it's very likely you won't be able to separate them like that. All right, I'm going to go ahead and do some more examples. Those are just small examples. Now we're going to start like our first official example. And directions for questions like this would just say simplify. And let's see, I'll write 2 on here at a time. So part A, we'll do 3x squared y cubed times negative 4 x to the negative 2 y to the negative 5. Part B, do negative 6a to the 5th b to the negative 1 over 2a to the 7th b to the negative 3. And I have more, but I don't want to run out of space or anything, so we'll do these first. Now, if we were in actual class, I would give you some time to do them. Because this is just a video, I just recommend that you pause and always try to do problems like maybe before I do them. So you can always pause the video and try to work it out on your own, but I am just going to get started. So this is just multiplication, so I'm just multiplying like terms. So the 3 and negative 4 will give me negative 12. X squared and x to the negative 2, those have the same base, and I'm multiplying, so I'm going to add those exponents. So that's 2 plus negative 2. And then the y's, I'm going to add those exponents, so that's 3 plus negative 5. And we're just simplifying, so this is going to give me x to the power of 0, y to the power of negative 2. And we're not done here because x to the power of 0 is just 1, because anything to the power of 0 is 1. And then also that y to the negative 2, you don't want to leave negative exponents. We can move that into the denominator to make it positive. And then multiplying by 1 doesn't do anything, so I can write this even simpler. And that's the simplest I can go. Now, when it comes to showing your work in this class, you may be able to skip steps. You might have even, for this one, been able to go straight to the final answer. Here's what I'll tell you about skipping steps or not showing work. If you don't show work, I can't grade it, meaning I can't give you partial credit. So let's say on a test or something, you stop here. So you don't simplify to the x to the 0, and then you don't simplify the negative exponent. You are going to lose some points for this question, but as long as I can see some work, you wouldn't lose everything. So you would get partial credit for this one. Next up, so I'm going to reduce the negative 6 over 2 first because I'm taking like terms. So that would be negative 3. The a's can reduce, and so we can decide if we want to do 5 minus 7 or 7 minus 5. My personal preference would probably be doing 7 minus 5. You got to be careful there because that does put it in the denominator. Since you're doing the 7 first, and since that's in the denominator, your answer's in the denominator. And then for B, I want it to be positive, so that's why I always want to take the bigger number. So I would do -1 minus -3. So again, the reason I'm doing it this way is I'm taking the bigger number minus the smaller number and then putting the answer wherever the bigger number was, whether it's numerator or denominator. And then I'm going to fully reduce. So let's see, this would be b squared over a squared. And this is fully reduced. We have all positive exponents. Now let's say you did it the other way and you did a 5 minus 7 and you did b -1 minus 3. Like let's say you just didn't you didn't do any of them like bottom minus top. You just did top minus bottom. This is perfectly fine. You'll just have a to the -2 b squared. And then since that a has a negative exponent, you'll want to move that into the denominator. But only the a gets moved because only the a has the negative on the exponent. So either way, you get to the same answer, just in a slightly different method. And I do have a part C and part D. Part C. This is -3 x to the power of a. So not a number. I'm actually writing a. Y to the -3. And it's all to the power of 4. And then part D, we're going to take 3a to the 2m minus 1 divided by 2a -3m. And this is all to the power of -3. Again, you should always pause and try to do the problem yourself. But I will, of course, do them. So for this one, this 4 is going to go to everything in here. So I'll have -3 to the 4th, x to the a to the 4th, y to the -3 to the 4th. And so whenever you have exponents separated by those parentheses, you're going to multiply them. Now, -3 to the 4th is 81. 4 times a, I can just write as 4a. There's nothing I can do there. I can't simplify any further. -3 times 4 is going to be -12, so that's y to the -12. Not finished yet, because I don't want a -12, I want a +12. So that's going to have to move it into the denominator. Now for part D, you can kind of start this in a few different ways. Some people may want to combine those A's right in the beginning. Some people may want to distribute the -3. It's a bit up to you what you want to do. Now, because I see that negative on the outside, I know that I can just flip the inside. So that would probably be my first step personally, but that's just me. And you don't have to do it the way that I do it. But I would just flip everything inside because of this negative. So that would be 2a to the negative 3m over 3a to the 2m minus 1. And this is still all to the third power. It's just I got rid of the negative by flipping everything. Now I'll go ahead and distribute that 3. So let's see, that's going to leave me with 2 cubed a to the negative 3m cubed, 3 cubed, and then a to the 2m minus 1 cubed. And I don't really need the outside parentheses anymore since I don't have an exponent there. So for these here, we're going to have to like multiply these exponents. 2 cubed is 8. 3 cubed is 27. So I'll go ahead and get that out of the way. Here I'm doing negative 3m times 3. So that's going to give me negative 9m. So I have a to the negative 9m. And at the bottom, be careful. This is 2m minus 1 times 3. Because of this minus here, we're going to have to distribute that 3. So this is actually using a topic that we will cover later, but we're actually seeing it a little bit now. So it'd be 6m minus 3. This will be a to the 6m minus 3. Oh, I didn't mean to scroll to the top. Now we can simplify this further because we have multiple of the same base. So that means that we can put the exponents together. In this case, since it's division, we're going to use subtraction to do that. And now you can choose if you want to do negative 9m minus everything else, or if you want to do the 6m minus 3 minus 9m. It's up to you. Or minus negative 9m, sorry. I'm just going to do it at top. But we got to be careful here because we're going to have to distribute this negative. Again, kind of using a topic that we'll cover more later. So negative 9m minus 6m, and that would be a plus 3. So I'm having to distribute there. One more step to simplify. We get 8a. Negative 9 minus 6 is going to be negative 15m plus 3 divided by 27. Now this is a case where we can't really get rid of having some kind of negative in that exponent. However, it might look a little nicer to say 8 over 27 a to the 15m minus 3, basically taking the opposite signs. I think either of these would be an appropriate answer if I'm your grader, because neither of them are really much better than the other. I guess maybe I like the positive 15m maybe a little bit more, but it's okay. So that's actually going to be it for R2. So that's it for this section. If you ever have any questions of a section, please send me an email and I will hopefully get back to you as soon as I can. But otherwise, I hope y'all are having a great day and I will see you in the next video. Bye bye.